Adding and subtracting polynomials. Remember that a term is a constant, a variable, or a product of a constant and one or more variables raised to powers. Examples: 5x squared, x, 17, and negative 6x squared y squared. So these are examples of, well, a term. They're all individual terms. Be aware of that. Notice the commas. Hence why I separated them on the side. A monomial is a constant, a variable, or a product of a constant and one or more variables raised to counting numbers from powers. Or similar to terms in others, just as a reference. So, similar idea to terms. A polynomial, or polynomial expression, is a monomial or sum of monomials. So we usually prefer to leave polynomial expressions in decreasing order. For instance, 2x squared plus 2x plus 3. Notice the highest exponent comes first. So in other words, the degree comes first. Degree of the term in polynomial refers to the exponent for a single term and the highest exponent for a polynomial. For instance, if you have 2x to the fourth, the degree is 4, highest exponent. Coefficient in a term is a constant factor of the term. For instance, 2x to the fourth, in this case, the coefficient is 2. It's the number in front of x to the fourth. So A, as an example, we have 2x squared plus 2x plus 3. And the idea is we normally want to simplify expressions. Well, if you have a hard time seeing this, well, one we can see is, let's think of the 2x squared referring as we have 2 boxes of oranges. The x squared means they're a box of oranges. Remember oranges? Yeah, that we can get an idea of what they look like, right? But imagine they're in a box. You don't know how many oranges are in that box. So we call it 2x squared, 2 boxes of oranges. And let's say, for instance, the 2x are boxes of mandarins. So there are 2 boxes of mandarin. Notice they both have an x, right? Hence the idea, they are orange color, they have similar shape, similar texture, right? But you can still tell them apart. Can you tell the difference between an orange and a mandarin? In most cases, you probably can, right? So, last but not least, let's refer to the last one as apples. So if it helps you visualize this with reference to these fruits, please use them, right? We can tell them apart in some cases, and that way we can defer or refer to them as different boxes of different fruits. Agreed? That's the main idea for this. To be able to tell them apart and notice what makes them different, and we can combine them together. Another example would be if we had grapefruits, if we had, let's say, 5x to the power of 3, grapefruit is bigger, right? It's the orange shape, orange color, orange similar taste, or I should say texture, not taste. But you can tell that the taste would be different. Agreed? A grapefruit versus an orange versus a mandarin. So just as a reference, if it helps you out, please use them as reference. But in this case, let's notice that 2x squared plus 2x plus 3, we can't simplify any further. We have 2 boxes of oranges, 2 boxes of mandarins, and we have 3 apples all on their own, right? So we can't combine them. They're all different fruits, essentially. Different boxes. We wouldn't want to combine them and sell them at the same price, technically, right? That's a reference. So degree. Degree is the highest exponent. In this case, the 2. Exponent of 2. Coefficients. We have 2 coefficients in this case. They're in front of the axis. And they're both a 2 in this case. Both is 2 for the coefficients. And last but not least is the one that has no variable. We define it as a constant. It's a constant. It's a number that's not going to change, ideally. So that's our constant. You may have seen this in the past. Hence the reason why it's not in the definition here. And once again, we can't simplify, so there's our answer. B. Remember, when you can't simplify, you want to at least circle your answer saying, I can't simplify, this is the answer. X squared plus 2 plus 4x squared plus x minus 6. Notice I kind of separated them a little bit more. Now we can see the difference or which ones are the terms. So we have a box of oranges plus 4 boxes of oranges that we can combine. 4 plus 1 gives us 5 boxes of oranges, agreed. And then we have, well, let's call those apples. We have 2 apples, and then somebody wants 6 apples. Well, it looks like I'm going to be missing apples, right? I won't have enough apples to give away. So combining the oranges, we get 5x squared, 5 boxes of oranges, in other words. And then notice the x is all by itself. There's no other x's that I can combine it with. So plus a box of mandarins. And then, once again, somebody wanted 6 apples, minus 6, but I only had 2 apples, right? So 2 minus 6, negative 4. I still need 4 more apples to be able to give them away, agreed? So in this case, that's as far as we can simplify. 5x squared plus x minus 4. 5 boxes of oranges, a box of mandarins, and we're missing 4 apples. That way we can tell they're different. We can't combine it. That's as simplified as it's going to get. And let's realize that the degree in this case is the 2. There it is, exponent, right? Degree is 2. And let's realize that our coefficients in this case is 5, and we can always put a 1 there, right? So 5 and a 1 before that x. So those are coefficients. Once again, the constant, negative 4, the apples, agreed? Very common. Okay, so that's as far as we can simplify, so there is our answer. And C, last but not least, we are missing, or somebody wants, a box of mandarins. And then plus 6 boxes of oranges, plus a box of mandarins, and then somebody wants 2 boxes of oranges. Okay, let's realize a box of mandarin minus a box of mandarin, they cancel out, right? So we can cancel out the box of mandarins. Mandarins are gone. But now we're left with oranges. 6x squared minus 2x squared. 6 minus 2 gives us 4, right? So we'll get 4x squared. 4 boxes of oranges left over. That's it. There's our answer. But let's realize that the degree is the exponent, the 2, and the coefficient is the 4. So once again, there's our answer. 4x squared. Once again, if it helps you to visualize this with fruits, try it out. If it doesn't, forget I mentioned the fruits. If it makes you hungry, I'm sorry. Okay, let's go on for the next portion. Leading coefficient. Leading coefficient in a polynomial is a constant in front of the highest degree. In this case, the 4, highest degree of the polynomial. So which is the constant in front of the highest degree? The 8. So in this case, the degree of the polynomial is 4, and the leading coefficient is 8. So always the number that's in front of the highest exponent is the leading coefficient. So below we have like terms versus unlike terms. We kind of already did that in the previous view, agreed? So let's backtrack a little to the previous view. Here we go. And let's realize that for A, our leading coefficient is 2, the first 2, right? The one that has the x squared. Leading coefficient for B would be the 5, because it has an x squared. And the last one, C, there's only one option, right? So leading coefficient is 4.